Forward, we call it forward calculation, and we have a backward calculation. So we have like this of latest time G. I'm sorry. Oh yeah, G. This one. Latest time calculation. Like this. And then we have slack. Slack for the event differentiate between early start and early start. So slack time is early start T minus with the early start J. Slack for the activity this is event E1 marked in G. The difference between the latest time event G and early start event E plus the estimated time needed to complete the activity. So this is the slack activity. In AOA, we have slack event, slack any nodes, and slack for the activity. So LTG with LTE plus N. So the next one, we call it a critical path. Critical path is critical event with slack event equal to 0. ET equal to LT. Critical activity is activity that highly sensitive to the delay. If the activity late, so the project, the duration to complete the project is delayed. This one, a critical activity. So the critical activity is activity with activity slack equal to 0, ET equal to LT, and ETG equality to G. So what is the critical path? The critical path is the path from the starting point to the end point in the network. Consists of critical activity, critical event, and dummies. That are they have a critical. The slack is equal to 0. All activity and event that have 0 slack must be in the critical path, and all activity and event whose slack is not equal to 0 must not exist in the critical path. The purpose to knowing the existence of the critical path is to quickly find out which activity and event that have the highest level of sensitivity to delay the project implementation. So, at any time, the priority level of project wisdom can be determined and wait for the critical activity. So, we can focus in the critical activity. If we run a project, we must pay attention to the critical path, because if they are late in the activity and in critical activity, so all of the project will be new. So this is how to monitor the project. We have some activity that must be have a priority. So this can be made for the critical activity. Okay. This is the example. We have activity and we have successor. Activity A, B, C, D, E, F, G. Successor B, C, D, E, F. It's and A, B, F duration. So we can make some project level. So we can bring the first and marks. This one AOA, activity of marks. So the first one, A, activity A, they have successor B and C. So this is activity A, and they have successor B and C. Okay. The next one, B is have a activity D, E, and B. They have a
D, E, F.
D, E,
F.
Okay. Activity C, they will it's okay. The event different is okay. 4 is G with G. Like this. E with G and E, G and
H.
E, okay. E, G and H. So for A, this Y must be connected to A, before A, like this. Yeah. And then H for this one. So we can make some adjustment. Like this. A, and then B, and then this one C, and then B, G, like this, yeah, and then G, A successor, the successor BC, and then B, the successor DE, and C, H, K, D, G, E, G, and H. So this is and then we can move this one. This C F A B C with H. So this is F H. C, and then D, E, F, and then C with H, G is with G, and then E, G, and H. So the H, like this. We apply everything. After E we have G, and after E we have H. F with H, and then G with I. So we can H with I. This is H. G, this is X. B, C with H, D with G, E, G and H, and then F with H, G, I, H, I. Like this, yeah?
What is the number for?
Oh, it's okay. I'm sorry. Okay. This is. It's okay. This is not really crucial. Not really crucial for the calculation, but only to make this is an event and only. So this is the duration. So duration. The duration is 8 and then 5 and then 6, 11, G, 2, E, 10, F, 7, G, 3, 8,
9,
9,
4.
Okay, so we calculate the earliest time and last time. So this is we start with 0. This is the starting time 0. And then we have duration. So this is the earliest time is 0 plus 8.
8.
Okay. And then in 3 we have 8 plus 5. 13. And we have maybe I have ada merah ya. It's okay. Yes. So 0 plus 8 is 8, 5, 13. And then 4 this one. 13 and 2 and then 15. But we continue. We must compare with from this step, because they have two row that put in this one. So we try to take the maximum antistas plus L. So we for the forward we look for the max. So this is 15, and because they have two row, so we continue with this one. 30 and 10 we have
23.
and 23. So 23 with 0 we have 23. Between 15 and 23 we have the max is
23.
So this one is and then for 6 they have 13 and 20. This is 8 plus 19. So the next is
20.
is 20. So we have 20. This is 20. Here we have different because they have 3 row. This is 19. This is 20, and then this is 23. So we choose this one. Okay. For 7, we have 23 plus 3, 26. This is 23 plus 9. So we have
32.
32. So the next one is
32.
32 plus 4 is
36.
so this is the duration. duration for completion the project. Complete the project. Okay. We have this one. We calculate for the forward calculation. So this is for early start. The next one we calculate for the latest start. This is from back. So we call it back. Okay. This is for 36. We minus with 4. We have 32 minus with 9. We have okay. 32 minus with the
3.
We have
39.
Okay, this is okay. 23 mean minus with 0.
33.
29 minus with 0. 29. For the letters, we take a look. We choosing for the minimum. For the letters, for the backward. For forward, we take a look for the maximum. But for the forward, we take a look for the minus. Okay. So this is we have 23 minus with 2. 21. 23 minus with 10 is 13. 23 minus with 7. So, the minimum is 30. So this is
43.
This is 23. 23 minus with 11, we have
12.
Yeah. This is 13 mean 5 is we have 8. The minimum
8.
8 minus with 8. So if we have earliest time equal to latest time, we call it this right. Equal to 0, and we have this is a critical event. So which are critical event? Which event? Event 1. This is the same. This is the same. And then 3.
Yes.
Yes. And then 4. 4.
No.
No. 5. Yes. 6.
Yes.
Yes. 7. Yes. Yeah. So the active for the critical activity we have A and then
B.
B and then
E.
and then dummy. This one dummy. Yes. And then H.
7.
H.
8.
So this is the critical activity, which is critical event. Okay. So the activity in the critical path, this is we call it critical path. AEWXI. This is a critical path. We solving this with critical path method. Okay. So this one, this is the same. We can calculate it with the table, or we calculate it like that. It's okay. Both of them is correct. Like this, select. So we can calculate with the table. We have like this, right? If the early start and later start is the same number, so the select is equal to 0, and then this is the this the critical path that we calculate. So this is 1, 2, 3, 4 because they have slack equal to 0, the same number. 6, 7, 8. So this is the slack method calculation, and we step by step using a table, but we can calculate it in the method like this. It is just it. So this is the critical path we have with the red lines. So the critical paths A, B, E, W, X. So this is calculation for critical.
Why is E the critical path?
Why?
Is E the critical path?
Yes, because this is the side. If we calculate about the side, we have the same between early start and the latest finish. The same have early start and latest finish. So we input it in the critical path.
Okay, what is it doing? The same value for
Yes, early start and latest time is the same. So the side is the same. If they have like this difference, they have a slide. The slide is latest time minus this one. This is the difference in it can be the activity can be delayed. That can be changed about the critical path. We learn it later in the next slides. So float or slack is great period of the activity. We have two types: total float, we call it slack activity, and free float. What is total float? Total float is total float for an activity E T is the difference between the maximum time available to execute the activity and its duration. So the float is latest time T minus with the earliest time A plus F. For free float, the free float occurs when it is assumed that all activities start as soon as possible. So earliest time T minus with earliest time B plus F. So if we calculate the table, so from the activity A until I, E until I1, this is the event. EG, total float is, this is the latest time. So total float is, we calculate total float is latest time G with earliest time E. So it's mean 0 plus x. So we use this formula to calculate about the total float and free float. This one. So we can calculate if we have total float equal to 0. This is input in the critical path. Like that. This is activity delay. What is activity delay? This is the time differences between the realization of the completion of any activity and the time for the completion of the activity. We have 4 conditions. The first one, the delay is less than equal free float. The second one is the delay is between free float and total float. The third one is delay equal to total float, and the delay is more than total float. We have 4 conditions, and it's depend for influence the critical path. The first one, if the delay less than equal to free float, this is a fixed project implementation time. They have the same duration for the project. If we have this one, like this one, even if the activity the delay is less than project implementation, the same with the before. Fixed critical path, this fixed critical path. At the start of the activity, the successor remains but changes pattern of the resource unit. For the example, if we have like this, we have total flow. Ini prosedur itu. If this is total flow, we have prosedur ini. Now, if the delay is only 1, so for this one, if the delay is only 1 day, so if we have 3 in this one, the critical path is the same with the previous. This is delay. So delay in non-critical activity. We discuss about delay in the non-critical activity. So if activity D, they delay only 1 day, maybe in the period of 1 day, so there is no changes in critical path. We try to calculate again. If this one D have 3 duration, they take one day. So this is 13 plus 3. This is 16. We looking for the maximum. The maximum is 23. So activity D delay only 1 day. It's not change about the duration and not change about the critical. So if the delay is lower than 3 flow, they only change this pattern of the resource. The next one, this is example. For activity D is 2 days, consideration for this. So they need 2 days. We can make example before is let 1 day. This is 8 day. So fixed project implementation is same like previous 36 day. Fixed critical path. Critical path is the same like this one. And then when the successor activity start, it remains only time 23. Same. Changing pattern of the resource. So this is if we make 2 days. The next one, if the delay is between free float and total float. So the fixed project implementation times still the same with the previous. Fixed critical path, and then when the successor activity start, it goes backward, changing pattern of resource need. Changing pattern of resource need. For example, activity D is 9 days late realization or completion. So the completion is 11 days. So we come this one 11 days. The realization is 11 days. So free float A is 11. This is
Sire.
this one. Okay, this one. Oh, I'm sorry. This is must be 8. So this is 10. So the project is. So if we have this one, the date is 8 delay, and then this is total flow. If the same, this is the duration. The beginning duration is 2. If the rate is with 8, yeah, this is so 10. So if with 10, we have the same project implementation, but the critical path is changes. If the delay is the same with the total flow, between total flow and free flow. Like this. If the delay is the same with total flow, so project implementation time is the same, but the critical path can be fixed or changed. Can be changed if the free flow from the calculation is this one. Okay. From the calculation for activity D, they have total is 14 and free flow is 14 and it's and then this is flow, total flow and free flow. If the delay less than free flow, like this, so this is the same critical path and the same duration for completion of the project. But if the delay is between free flow and total flow, this is still have the same project information time, the same critical path, like this. Duration, sebelas, ya, fixed project implementation is same. Okay. But if the delay is equal to total flow, the fixed project, the critical path can be changed. So like this, if the total flow is 14, so they have a rate. This is 14. The duration 14 days late, completion realization this. So the implementation time is 39 days, and we have different critical paths, so ABEWHI and ABEWGI. If we have some rate, this is more than total, the pattern is changing. If they have more than total flow, the duration of project may be increased, and critical project can be changed. Successor activity start is postponed. Changing pattern of the resource, like this. The duration if we 5 days late, the duration 70 days. So the duration of the project became 32 days. Critical path become changes, and this is changing pattern of the resource, like that. So if less than free flow, this is no changes in the duration and critical path. But if they are more than total flow, they will be changed the critical path and the duration. Okay, any question? Maybe before we move to activity or not, this is easier than activity or not.
Sorry, Bu.
For the exam, maybe you can choose between AOE A. Activity on arts of notes or activity on notes. So, in the activity on note, they still have a restart. The first start of the activity start, and then the second one is always finish. Plus the start of activity started, and let the start, so start activity started, and the latest finish, so start activity. So, if we will in activity notes like this is very simple because the notes is the activity on the notes. In AOA, we should no? So A, they have successor. What is B? They have successor. Okay, and then P, they have successor. D, they have successor. E, they have successor. Okay. C, they have successor H. Okay. D, they have successor. And then E, they have successor G and X. Okay. And then F, they have successor H. Okay, and then F, H, and then G, they have successor H, successor. Very simple. We have no dummy activity. Duration, we have this is depend on the so we have 8 and then 5, 11, 2, 10, and then 7, 3, 8, and like previous, we have a restart. This is 0 plus 8, 8. This is 8 plus 5, 30. 8 plus di sini 8 plus 11. Okay. For this one, okay, jadi 13 plus 2,
15.
This is 13 plus 10. This is 13 plus 7. Okay. Any question? The same like before. This is G. G they have from D and from E. For the forward, we take it for maximum. So this one 15 or 23. 23 plus 6. And then for this one, this is 23. This is 20. And then this is 20. So 23 plus 8. This one 26 and 32. The maximum is plus 4. The same. We have the same final for AOA and AON. This is for forward, for backward. So this is 36, 32. This is 32, and then 23. This is 32, and then 20. Okay. For this one, we have 23. 23 minus 7. We have
16.
And then we from this one 29, and for 23 we taken for the minimum value. So this is
3.
3 minus with 10. This is
39.
minus with 2.
37.
For this one we take for the minimum 27, 13 and 16. So this is 13.
880.
This is 23 minus with 11.
12.
12 and 8. So this is
8.
okay. Easy, very easy.
Easy.
So this is the calculation. If we have AOA activity or not, we have some like agent. This is early start, IT, early finish, latest start, duration. This. So we calculate for the forward and backward. This way, we start, we finish, and we have select in this one. This one. Yes, select. So we calculate the select from the early finish, like early finish minus with the early. This is like this finish minus with the earliest finish. So we have this like this. So we can calculate that we have a select equal to 0. This is the critical path. So we can take this is activities A, B, and then E, and it's
H.
this is the critical. Okay, any question? Sangat mudah, easy, very easy. So this is the other example for the network information like this. So A, B, C, D, E, F, G, G, H. So the forward pass computation and activity types of each byte in the network. Early start plus duration. Carry the early finish to the next activity where it become the early start. Unless like previous we have another path that include the nodes that have maximum point. This activity backward, so backward and forward. Yes. So we can determine the select or fruit. Free select, the amount of the type activity can be 0. Total select, the amount of time an activity can be delayed without delaying the entire object. The critical path in the network path has at least select in the any question? This is for critical path.
Sorry, Bu, I don't see any difference between the first one. Does it? Yeah, does it use also the same algorithm for this and the last one?
The previous one. What do you mean with the previous one? AOA.
Yeah, AOA.
AOA. This is the frequency. For the calculation is the same, but for the network is different. Like this one. A
Oh yeah,
is
the
on
dummy.
X.
Yeah, okay.
We calculate in the given, but in this we calculate in the activity. This is more easier than AOA. because they have a dummy activity. We must calculate select for event and select for the activity. But in this AOA, we only calculate for the selecting the activity. Okay, but the calculation is the same. The calculation is same, but for the network is different. This is the two approaches. We can choose any student. They prefer to use AOA, but other student they prefer use AOA. This is they have good perspective. Okay. Any questions?
So we use AOA if there is a dummy in the maybe the question for exam.
Sorry, if there is a dummy, we calculated with AOA. But there is no dummy, we can use AOA. If in the exam or in the exam no written use AON, you can choose anything between AOA and AOA. If no other instruction is defined in the exam.
Okay, thank you.
Any other question? This is AON, AOA, AOE. The next one, the second method after this method is called critical path method. The second one is called program evaluation and review technique. We include a little probability, but for the calculation is the same with CPM. The calculation is the same with CPM, but they have a probability for the duration. This is the difference between CPM and PER. For the calculation is the same, but for the duration is this difference between CPM and PER. For CPM, they have fixed duration or deterministic duration. But for the PER, we have a probability. So we calculate about the average time. Because in a project, maybe we have a time that has optimism and we have a pessimism. So in the PER, when there is an uncertainty in estimating the time, it will take to complete the activity, and it is important to effectively control the project schedule. In PER, the duration of the completion of time is predicted with 3 activities time. The first one is optimistic time. So we define this as A, and then normal time, most likely estimate, and then pessimistic time, pessimistic estimate or B. So we have A and M. M is most likely, A is optimistic, so the duration is shorter. This is pessimistic, this is lowest. Then the other time. So optimistic time is a time is taken to complete an activity, assuming that the implementation of activity is going very well. The fastest possible time to complete an activity. This we call it optimistic time. For pessimistic time is the time is taken to complete an activity, assuming that the execution of the activity goes very poorly. So possible delay is completed effectively. So we have pessimistic time. Normal time is the time is taken to complete an activity, assuming that the implementation of the activity is running normally. This is we have 3 estimated time in the PER. So we have the probability distribution of 3 time estimate is symmetries, like what is called with probability
Normal.
is normal, and then can tilt to the left, to the right, controlnya For the project, we follow the beta distribution approach. Beta distribution. So we can calculate average project completion time is equal to A plus 4M plus B per 6. So we make average with this variance. So we B mean A per 6 square. Like this for the example. So this is the activity. This is the predecessor. So we can in equation we can make this is successor or predecessor. This predecessor is the previous activity. So A, B, we have predecessor A like this. This is we have optimistic time, normal time, and pessimistic time. So we calculate the average of the time. So the formula is 2 plus 4 multiplied with 4 and plus with 6 per 6 we have 4. This one for variance is B in A. So 6 in 2 per 6 square. The quadratic
Power.
power. So we calculate the time and the variance. The critical path. This is using AOA or AOM. For this one, AOA or AOM. AOA or AOM. AO because activity in this. So they So to input to calculate in the per method, we use this one. So activities A, they have duration 4 like this. To calculate it like in the critical path method, this is the same, but only the difference is in this one. So the duration we must calculate before we solving with the CPM. This is the same like so this is A 0 plus 4 plus 8 12, and then this is 4 plus 7, this is 12 no, this is from this one. 4 to 7 is 11, but 12 maximum is 12, so this is 12. And then for this one, this is 4, 8, 12 plus 8, 21. This is 4 plus 6, 10. So the maximum is 21. 21 plus 12, we have 33. This is 12 plus 15, we have 27. So the maximum is 33. Plus 8, 40. The same like before. If we take a look like this one, what is the critical path? So we have this one. 1, 2, 3, 5, 6, 7. So the activity A, C, F, G, H. This is the critical. So the same. So for average project completion time is equal to 41 like this. And project completion time variance only for the critical path. So this is A, AC. So this one for the project completion time variance is only in the critical path. So this is for A, C. C is 1.778. only in the critical gap. Not all this one is sum. No, not some of the variance, but some of the critical path activity. Standard deviation, so we square this variation. This is the example. The other example. Probability of project being complete in less than 8 days. So we can calculate with this one. Probability T less than 8 is probability with Z32 Z from the probability distribution normal probability. Z this is less than n being T average T variance. For example, the probability of a project being complete in less than 45 days is 45 mean 41 is from this one, variance from this one, I'm sorry, standard deviation from this one, standard deviation, this is standard deviation. So this is the probability of project completed in less than 45 days minus with the completion time per standard deviation, and we have Z less than 1.35. So we take a look at the normal distribution. 1.35. So this is the probability 0.91. This is or 91. This is we use normal distribution. He said that we can define the X% confidence interval of the project estimated time. So we can calculate T means Z alpha 1, 2. This is 6 1. This is minus. This is plus. So we can calculate the 95% of estimate project time confidence interval like this. This is the probability of completion time minus with Z. If this is alpha 5%, so we have alpha 2 is 0.025, and then this is for standard deviation. We take a look at this one for Z0. No, this we have 1.89. So this is for minus. This is for plus. So this is the interval. The interval 95% of estimated project time confidence. So we can calculate. Okay, any question for this?
Why do we need the optimistic data?
Because in the reality, the project is not in a fixed time. We have optimistic, pessimistic, and most likely.
I mean, based on the calculation about the
Because we know that maybe this activity is going very well. There is no constraint, they only consume less duration. So we must take optimistic duration.
Does that also change like the formula also, like the probability, like it goes higher than 45 for example? Like in here, the example is we use the pessimistic time, right?
It is what?
The first example.
The first example is what?
Like, yeah, the project completion time duration.
Is what? We must have, for the core method, we must know about the optimistic time, pessimistic time, and most likely. So we can search for the average of this time. In the reality, we don't have any fixed duration, because maybe they late or they earlier than the time. So this is only for the calculated for the average duration only. For the input, we need for the optimistic, pessimistic, and prospective.
Maybe for the time completion variance, like we calculate the pessimistic, some of the pessimistic, right? How about the optimistic one? Like, do we need to calculate anything about it?
Yes, for the variance we calculate for the pessimistic with optimistic. For the average, we need these three of this type. We must need the optimistic, we need pessimistic for calculate the variance and for the variance.
To calculate the variance, okay.
For the variance, we know the difference with the optimistic and optimistic. Semakin jauh itu perbedaan. Kalau semakin jauh variasinya besar. Nah, itu berarti kalau semakin jauh variasi besar, berarti di situ kendalanya mungkin berubah. In reality, this method makes sense because in the project the time is not fixed.
Thank you.